Good day everyone, this is my solution for FA 1.4-2 about epsilon NFA conversion. So for question 1, we are asked to convert an epsilon NFA into an NFA without epsilon transitions. So first, I computed the epsilon closures of every state. So the epsilon closure of Q0 is Q0, Q1, and Q2 because Q0 can reach Q1 using epsilon, and Q1 can also reach Q2 using epsilon. So the epsilon closure of Q1 is Q1 and Q2, and the epsilon closure of Q2 is Q2, and the epsilon closure of Q3 is Q3 because they do not have epsilon transitions. So after getting the epsilon closures, I constructed the equivalent NFA transition table, and I constructed the equivalent NFA by replacing the epsilon transitions with direct transitions using the epsilon closure method. So next I completed the new transition table, so here it is. And then the start state remains Q0, and then the accepting state is still Q3. So the resulting NFA accepts the same language because all epsilon transitions moves are already included in the new transitions. So here's the original NFA diagram and the final NFA diagram. And for question 2, we are asked to convert the epsilon NFA into a DFA using subset construction. So first, I computed the epsilon closure of the start state, which is A, and the epsilon closure of A is A and B because A has an epsilon transition going to B. So this becomes the start state of the DFA. So next, I applied subset construction. So from A, B on input 0, the result is B. And then from AB on input 1, the result is C. So from B on input 0, it stays B, and then from B on input 1, it goes to C. So from C, both inputs 0 and 1 stay at C. So the accepting DFA state is C because it contains the accepting state C. And the DFA is deterministic because each state has exactly one next state for every input symbol. So the DFA is also equivalent to the epsilon NFA because subset construction preserves the language accepted by automata. So that's all, thank you. And here is also the original epsilon NFA diagram for question number 2 and the final DFA diagram for question number 2. So thank you so much.